itself, which often has a massing effect. Each individual may have a differently, according to this sighting handbook, each individual may have a different sensitivity to various types of noise. In some situations, those who are opposed to or not part of the wind project may be more annoyed by the sound than those who are in favor of or directly involved in the project. Many communities have specific noise limits at property boundaries in nuisance provisions of their local ordinances. Alternatively, if a combination of mitigation measures, such as what are discussed below, is not sufficient to meet noise limits at specific sites, then a zoning variance or a special approval might be negotiated with local officials, typically involving some form of compensation for affected neighbors. And that's just basically an overview from the American Wind Energy Association. Here's a thing from the, this is from the Department of Energy and Climate Change in England. This was as of March 17th of 2011. Government study into the problem recommended that wind turbines are no longer built close to homes. The report commissioned by the Department of Energy and Climate Change suggests that turbines should be more than 10 rotor diameters from properties, which had to be 3,300 feet here at the 330 total. An average turbine with an 80-meter diameter would need 800 meters from the nearest home. This lady was quoted as saying she's sick to death of the flicker caused by turbines from the a half mile from her home. You can't sit in any room when the sun is setting at certain times of year. It's flashing strobe light. It's quite upsetting not being able to sit in your own home. People think you're barmy. They think you're after compensation, but all we want is our home back. The report went on to say that there's no significant health risks, but it does not include the day-to-day problems faced by people living near the turbines. The report recommended that homes and offices within 500 meters of the turbine should not suffer flicker more than 30 minutes per day or 30 hours per year. The report suggests the developers should implement measures around the turbines that would stop the significant nuisance caused by flicker. These include shutting down the turbines during periods of the day or during sunny months. Energy Minister Charles Henry said, "It is vital that we use the most up-to-date, robust, accurate scientific evidence when looking at the impact of wind farms on community. This study will be helpful to communities and developers and planners in their assessment approvals on onshore wind projects." That's from the Daily Mail. And then this comes right off the report prepared for the Department of Energy and Climate Change, and this is out of their conclusions. I didn't print out the rest of it, but you can find that online. Shadow flicker issues were resolved using turbine shutdown systems, which are standard mitigation approach adopted across Europe. Current guidelines to assess shadow flicker in the comparison guide states that impacts occur within 130 degrees of either side of the north of the turbine. This has been found to be acceptable metric. Additionally, the 10 rotor diameter rule has been widely accepted across different European countries and is deemed to be appropriate assessment area. Although there is potentially a need to differentiate between appropriate assessment areas at different latitudes, this is an area where scientific evidence base could be readdressed. Careful site design to eliminate shadow impacts is important, with mitigation measures such as turbine shutdown system being used regularly. Whilst the industry software that we reviewed can only be used to carry out the worst case shadow flicker assessment, there is perhaps a need to address the worst case and realistic shadow flicker assessments. And the developer just says that they're going to be 30 hours less than 30 hours a year on their paperwork. So, and then I have the same one that Greg had on this, on the ice drill and ice shed. So you already have that. And then I have this one, and this comes from a professor. This is Professor Terry Matilsky, Department of Physics and Astronomy at Rutgers University. He's from Rutgers, and this is basic kinematics. Bottom line is that ice debris or anything breaking off the wind turbine blades, including the blades themselves, can impact the point almost 1,700 feet away from the base of the turbine. Thus, the total range of projectile is 1,400 feet times 3. Well, it goes through it, and this is something I just added for myself. While the developers tout that the results as being representatively not decidedly untrue, they ignore McQueen's '83 study that concluded that a maximum range of 800 feet, or about 2,500 feet, was quite possible. Indeed, even a maximum of 2 kilometers over a mile was conceivable. Incidentally, as near as I can see, the McQueen study is only the only peer-reviewed analysis of throw possibilities. The rest are calculations done by wind company employees or consultants. Part 4, throughout these discussions, the wind developers have been groping for setback distance that they can live with. They started with 1.5 times the ground tip distance, about 150 meters. Near as I can tell, this was just pulled out of a hat. In physics, we call this a toy model. Then the distance was increased to 200 meters in several papers. Now in a recent paper, 400 meters is quoted. They're getting closer to my original number. In the beginning, the claim was that the rotor sensors would stop the blade because of ice buildup. Now even the papers put forward by the companies admit their error here. They state rime ice formations appear to occur with remarkable symmetry on all turbine blades, with the result that no imbalance occurs and the turbine continues to operate. Another failure of their initial assumptions and models. In conclusion, there are some problems with wind turbines that have unavoidable consequences. Birds will die, bats will die. In these scenarios, you need to adopt risk analysis study. But here, you can eliminate the entire problem if you just adopt a conservative value for your setbacks. And this is Professor Terry Matilsky, Department of Physics and Astronomy at Rutgers. Okay, and this is a summary of wind turbine accident data from June 30th of 2010. And this one, because we were looking at data on blade failure. Pieces of blade are documented as traveling as up to 1,300 meters. In Germany, blade pieces have gone through the roofs and walls of nearby buildings. This is why the CWIF, which is who did this study, and they're the Caithness Wind Farms Information Forum, should be a minimum distance of at least 2 kilometers between turbines and occupied housing in order to adequately address public safety and other issues, including noise and shadow flicker. And under ice throw has been reported 140 meters. Some Canadian turbine sites have warning signs posting asking people to stay 305 meters from turbines during icy conditions. These are indeed only a very small fraction of actual incidences. A report published in 2003 reported 880 icing events between 90 and 2003 in Germany alone. 33% of these were in lowlands and on the coastline. That's that one. And this is their stuff, and that's the end. And this is just what they have and what their setbacks are, those 1,325. So what I get summary out of this is that the distances that we're getting from this, I mean, with the guy from Rutgers, that's a professor in physics, saying 1,700 feet for ice throw and for blade failure is a long distance from the 1,320 that they're offering. And also a lot of the noise impacts and everything else on there. And so my concern is keeping them farther away than the 1,320 they're suggesting, but yet still putting out a distance there that they can still install a turbine here or a turbine there. So that way they can still go and construct some, but I think the farther away than the 1,320 definitely needs to be addressed on this, because I think that's too close. Because it's such an unknown with the 1,320. If they had problems at 1,000 feet with 390 footers, I can't imagine moving back 1,320, but it's going to be less of a problem. And especially with the chance of ice or the blade going apart or whatever, you know, farmers go under there and farm all the time, you know, and I know they won't be there out in ice, but one fails while they're out there farming, it's not going to be a happy day. And if they're going through buildings over in Germany and stuff like that with turbine failures, there's obviously issues.
I wonder if turbine height also has a
well, right, that was only 80 meters.
Effect in there.
I mean, I think he's talking only 80 meters. And what are these?
These are about 130 meter.
So you got to go and multiply that. This guy did it off of 80 meter height. So
80 meters about 250, 260 feet.
Right. So that'll multiply it more if he's got the math and the study in there how to go and figure this out as a physics, as the professor of physics at Rutgers. And he said if you have any questions, you can call him or email him.
Okay.
So I mean, if it's 1,700 feet, we just say, think about it, it's another, what, 50 meters? So go and maximize that and move it out farther, and that's where he's at the 2,500 feet to, you know, so that's getting scary. I mean, I know it doesn't happen that often, but one chance is all it takes.
Okay, the next document I have is called State and Provincial Land-Based Wind Farm Siting Policy in the Great Lakes Region, Summary and Analysis. This is written by Victoria Peebles, Program Director at the Great Lakes Commission for the Great Lakes Wind Collaborative. January 2010. The document provides a comparison of how the states that border the Great Lakes address wind energy policies in their own ways. Basically, some states require permits at the state level, some states have recommended guidelines, some states have centralized siting boards, they review and approve the request. Some states leave the responsibility of regulating and siting wind energy systems to the local townships and municipalities. Michigan, at the state level, does not have regulatory authority for siting wind projects and has developed siting guidelines as an aid for local municipalities. Common elements of the state wind farm siting policies and guidance include environmental, cultural, archaeological, public health and safety, visual audio, navigable airspace, and electromagnetic interference. And it gives a little definition of each one. The document references Michigan guidelines, sample zoning for wind energy systems, which we've already gone through, as providing guidance in regulating property setbacks, sound pressure levels, safety procedures, including minimum vertical blade tip clearance from grade, visual impacts, and electromagnetic interference. Sample zoning reference also recommends municipalities to require several plans or assessments as follows: third-party environmental impact assessments, third-party avian and wildlife impact assessments, analysis of and plan to manage potential shadow flicker, decommissioning plan, and a complaint resolution plan. The document makes reference to an October 2009 Wind Energy Resource Zone Board issued a report identifying 4 geographic areas in the state with the greatest wind energy potential. Lenawee County is not in one of those regions. And the 4 regions, I've got them here. Region 1 is Allegan County. Region 2 is Antrim and Charlevoix counties. Region 3 is Benzie, Leelanau, and Manistee County. And Region 4 is Bay County, Huron County, Saginaw, Sanilac, and Tuscola. And on the maps, I have a map here as well. But anyhow, the 4 zones, there's one up here near Traverse City, one just a little ways south of that on Lake Michigan. The 3rd one is down here along Lake Michigan as well, and then the 4th one is the Thumb area. Those are the 4 areas in Michigan that have the highest wind energy potential. And the last document I have is called The Effects of Wind Farms, Lincoln Township, Kewaunee County, Wisconsin. And what this is this is a newspaper article that talks about a report from Lincoln Township's Wind Turbine Moratorium Committee. So here's some of the information provided in it. The utility scale wind turbines became operational in June 1999. And if I remember right, there were 22 turbines installed in this area. And they were, the company that did this was Wisconsin Public Service Corporation and Madison Gas and Electric. They went online in June of 1999. After that, Lincoln Township established a wind turbine moratorium committee to study the impacts after the turbines became operational. The committee was supported by an 18-month moratorium to allow time to gather information for the study. The committee surveyed residents for their feedback on whether or not wind turbine issues were causing problems in their households. Responses were summarized in the final report. So here's some of the information they got back from residents. Key elements of the final report are as follows: shadow flicker. Residents within 800 feet to a quarter of a mile, 33% said yes, they experienced that. Residents within a quarter of a mile to a half a mile, 41% said yes. TV reception degradation. Residents within 800 feet to a quarter of a mile, 33% said they experienced that. Residents within a quarter to a half a mile, 37% said yes. Blinking lights representing flashing windows after the dark. Residents within 800 feet to a quarter of a mile, 9% said yes. Residents within a quarter of a mile to half a mile, 15% said yes. Noise complaints, residents within 800 feet to a quarter of a mile, 44% said yes, they had that. Residents within a quarter of a mile to half a mile, 52% said yes. Other problems or information, they mentioned increased lightning strikes in the area, hazardous traffic conditions during and after construction, awakened by sound coming from turbines, residents within 800 feet to a quarter of a mile, 67% said yes. Residents within a quarter of a mile to half a mile, 35% said yes. And then how close to wind turbines would you consider buying or building? And 61% said not within 1/2 mile of turbines. 41% said 2 or more miles away from turbines. 74% said not within 1/4 of a mile. The township maintained a noise complaint log, and over 90 complaints were logged in 1 year.